Pulsar Fusion has recently revealed a bold 2 megawatt nuclear fusion drive. It is designed to provide both power and thrust in space for interplanetary vehicles. With a payload of 2 tons and a top speed of 500,000 miles per hour, the vehicle can potentially reach Mars in a few months or even Saturn in a couple of years. The approach they are taking is very unique in the fact that they are utilizing aneutronic pairs, which is deuterium and helium-3. So instead of massive amounts of neutrons, which is highly iodized radiation, they are producing protons. There would be 2 linear drives with superconducting coils, and this would send the plasma down to a diverter and maintain high exhaust speeds. The Sunbird vehicle would incorporate this drive and act as a modular, isolated system which can attach to other spacecraft. It would feature multiple Hall effect thrusters for maneuvering and attaching to these other vehicles. However, this type of drive has not been built before, and Pulsar is coming out with a very extreme claim that this can not only produce power, but produce thrust as well, which is something that has not been tested before in space. The main advantage to utilizing a fusion drive is that it has high specific impulse. This is often abbreviated as ISP, and it measures the efficiency of the engine by indicating how much thrust is produced per unit of fuel consumed. So in a typical chemical rocket, you might have a specific impulse of around 400 seconds, where a fusion drive can produce over 10,000 seconds or higher. And this is why there's so much hype about this drive, because they can produce a lot of thrust for a given amount of fuel, so they can be very efficient for long-distance space travel. But one thing to keep in mind is that they're very similar to Hall effect thrusters, where they produce low thrust and they can't get into low Earth orbit. But once you're in space, you're good to go, and this is a really good drive for interplanetary travel. So it's highly probable that a lot of this direct drive is actually based off the PFRC, which is Princeton's Field Reverse Configuration Direct Fusion Drive. And in this setup, it utilizes radio frequency waves to drive an electric current and then heat the plasma. Units are very small, 4 to 8 meters long and about 1.5 meters in diameter. However, there's been problems with the design showing that plasma loses 40% of the fusion power's radiation, with only 22% of the power recirculated back to the RF system. Now the plan is that there is going to be another PFRC-3 device which has a 10 times stronger field and an ion temperature of around 10 keV. The RF system has a huge power demand of around 200 kilowatts. So if the PFRC-3 can be self-sustained, then it probably means that Pulsar Fusion's propulsion device is more feasible. The problem with all this is that there needs to be new variations of the PFRC just to produce fusion power. Pulsar is claiming that they will have an in-orbit demonstration of the Sunbird by 2027. So the question is which components will actually work by 2027, and will this device even produce power? It is true that they can utilize machine learning to understand how to control the plasma better, but this is a really optimistic timeline. So another fusion drive concept which I highly recommend to check out is from Helicity. And they plan to use helical shear flow, or Taylor states, to confine the plasma. Instead of superconductors, they are actually using coils and double pulse current to confine the magnetic field and compress the plasma. In essence, it kind of acts like a 4-stroke engine with plasma injection, magnetic reconduction, compression, and then plasma ejection. So the intriguing thing about this project is that it's probably more scalable, and they plan to build a 100 kilowatt unit for 7,000 seconds of specific impulse on a 7-ton drive. The company also claims that the initial prototypes will just run off solar electric power instead of the fusion process itself. So it could be argued that this concept could be executed into a prototype more easily, and it could shed light on whether or not this type of drive is feasible in the first place. Regardless if Helicity and Pulsar Fusion meet their promises or not, there is luckily a lot of research going into field reverse configuration. Helion has just crossed over $1 billion in funding for developing a 50 megawatt reactor that can produce power by 2028. Now, that might seem crazy because we all thought it was 20 years away, but their design utilizes high-powered electromagnetic coils to fire the plasma against each other at 1 million miles an hour. The plasma merges, and more coils increase the magnetic field up to 10 Tesla, essentially compressing it and raising the temperature up to 100 million degrees Celsius, which is ideal for fusion condition. This fusion produces a magnetic field and induces current back into the magnetic coil, thus producing electricity and hopefully net energy gains. The cycle happens very fast, roughly a millisecond, and then it starts all over again. Once again, they plan to utilize deuterium and helium-3 to get around radiation problems and to have proton generation, but helium-3 is a very rare source, and we might even have to go to space to mine that, which is a little bit of a contradiction in this video. TAE is also building several prototypes, with the latest norm utilizing hydrogen boron reaction. Once again, the plasma would collide in the middle, and a neutral beam would heat the plasma further to fusion conditions. However, they have yet to build a prototype which produces net energy gains, and this exemplifies what I was kind of saying before on how hard it is to generate electricity from fusion. So direct fusion drives are very, very appealing in space because they can not only produce megawatts of power, but be one of the fastest space propulsion systems out there. Now, I'm a little bit skeptical on the timelines of the Sunbird because I don't think it's going to come out in the next couple of years, to be honest. And I know I'm going to get some flack for that, but we have yet to make a field reverse configuration nuclear reactor on Earth which can even sustain itself, let alone produce power. So I doubt that Princeton Satellite Systems has some secret in the bag and they have a direct fusion drive which can immediately go into space. However, having said all that, I still think that this is a potential game-changing technology maybe within the next decade. And if that happens, then we can finally have true space civilizations. So anyways, let me know what you think about all this. So please like the video if you enjoyed it, and also make sure to subscribe to my channel.